Hello students. So fifth set of properties in inverse trigonometric function, in which the first one 2 tan inverse of x is equal to sin inverse of 2x by 1 plus x square. So first consider RHS. It is sin inverse of 2x divided by 1 plus x square. Now recall one formula from trigonometry, that is sin 2 theta is equal to 2 tan theta divided by 1 plus tan square theta. Why it must be recalled from the first PUC. Just compare this expression 2x by 1 plus x square. It's exactly matched with 2 tan theta by 1 plus tan square theta. So substitute x is equal to tan theta in RHS. So you will get sin inverse of 2 tan theta divided by 1 plus tan square theta. What is 2 tan theta by 1 plus tan square theta? Yes, it is nothing but sin 2 theta. And from the property of inverse trigonometric function, that is sin inverse of sin x is equal to x, this will become 2 theta. Now what is theta? We substituted x is equal to tan theta, right? So this implies theta is equal to tan inverse of x. So substitute this back here, we will get 2 into what is theta? Tan inverse of x. Now see the question, this is nothing but LHS, right? So therefore 2 tan inverse of x is equal to sin inverse of 2x divided by 1 plus x square. Along with this proof and the statement, remember this domain. This will be useful for 1 mark question. Mod x less than or equal to 1. This is useful, or this you can use only if mod x is less than or equal to 1. This proof is important for 3 marks. Understood? Remember the result? 2 tan inverse of x is equal to sin inverse of 2x by 1 plus x square. Yes, next one. Almost similar. So I'll prove this third one. Okay, I'm not going to prove, you have to try yourself. See the second proof. Again take RHS. What is RHS? Cos inverse of 1 minus x square by 1 plus x square. Yeah, recall one trigonometric formula. What is that? Yes, you are right. Cos 2 theta is equal to tan 1 minus tan square theta divided by 1 plus tan square theta. Now when you compare these two, anyone can tell that you are going to substitute x is equal to tan theta in RHS. So what is RHS after this substitution? Cos inverse of 1 minus tan square theta divided by 1 plus tan square theta. Again using same formula, this will be cos inverse of cos 2 theta. Just like the previous one, here use again one more inverse trigonometric formula, that is cos inverse of cos x is equal to x. So because of this, you will get 2 theta. What we substituted in the beginning? Yes, we substituted x is equal to tan theta. So this implies theta is equal to tan inverse of x, and substitute this back here. So this will be 2 tan inverse of x. Now see the question. Yeah, this is nothing but LHS. So we proved 2 tan inverse of x is equal to, is also equal, because already we have one expression in the previous result. This is also equal to one more answer, one more formula, that is cos inverse of 1 minus x square by 1 plus x square. This is again an important proof for 3 marks. Here remember this substitution. How to decide this substitution? Using trigonometric formula. As well as for 1 mark purpose, remember this domain, that is x is greater than or equal to 0. You can use it only for x is positive real number including 0. Understood? Yes, third one I'm not going to prove. It's your work. You have to remember, you have to prove this using one trigonometric formula that I'll give you as a hint. Okay, that formula is, yes, right, tan 2 theta is equal to 2 tan theta divided by 1 minus tan square theta. So using this hint, try this yourself, write in your notebook. So these are the 5 different set of inverse trigonometries. Okay, as a formula you should remember, as well as you have to remember, you have to learn its proof also. All these proofs are for 3 marks. So one more set of properties we have in inverse trigonometric function, that is property number 6. Property number 6, in which first set, the first formula, sin inverse of minus x is equal to minus sin inverse of x for x belongs to minus 1 to plus 1. Again, this is one very important property. It will help you to find inverse trigonometric functions of negative numbers. Proof is also important for 2 marks. Remember that it is important for 2 marks. Here consider sin inverse of minus x is equal to y. Consider sin inverse of minus x is equal to y by some real number. So this implies, from the definition of inverse trigonometric function, this will become, we are just taking sin inverse into this side. Okay, so minus x is equal to sin y. So this implies x is equal to minus sin y. X is equal to minus sin y, and I can write this minus sin y as a sine of minus x. Yes, minus sine y is equal to sine of minus y. Yeah, using the first PUC trigonometry formula, sine of minus theta is equal to minus sine theta. Again take this sine into this side. So this implies minus y is equal to sine inverse of x. So therefore y is equal to minus sine inverse of x. So what is y? In the beginning we substituted y is equal to sine inverse of minus x is equal to minus sine inverse of x. So this is a very important proof, as I told, for 2 marks, and result is also very useful. So sine inverse of minus x is equal to minus sine inverse of x. The second one, cos inverse of minus x is equal to pi minus cos inverse of x. Cos inverse of minus x is equal to pi minus cos inverse of x. So proof again important and simple, just like the first set. Again take here cos inverse of minus x is equal to y. This implies minus x is equal to cos y. This implies x is equal to minus cos y. Now how to take this minus sign inside? How to take this minus sign inside? You can't take like this, because cos of minus theta is not minus cos theta. So you should use one more property of inverse trigonometry, that is cos of pi minus y is equal to minus cos y, because it is in second quadrant. So I am going to write now this as a x is equal to cos of pi minus y, right? Yes. Now take this cos into this side. So it becomes pi minus y is equal to cos inverse of x. We need y. So take y into this side. Take this cos inverse into this side. So pi minus cos inverse of x is equal to y. So what is y? Y in the beginning we took as a cos inverse of minus x. So hence we proved cos inverse of minus x is equal to minus cos inverse of x. So remember, cos inverse of minus x is equal to pi minus cos inverse of x. The third sentence, the third property in this set is tan inverse of minus x is equal to minus tan inverse of x. This proof is same as that of the first set, that is sin inverse of minus x is equal to minus sin inverse of x. Using this hint, you should try this, that is tan of minus theta is equal to minus tan theta. But remember, all these 3 statements are very important in problem purpose. Okay, so these are the 6 different set of properties of inverse trigonometric function. Thank you.